We already know that the utilization of a truck, or even any other types of vehicles, takes quite an impact on the CO2 production. Therefore, we look at a calculation of emissions of a truck with a partial charge. In our subsequent calculation examples, we take an underutilized tractor compared to a well-utilized tractor. In our first calculation example, we assume a bad utilization by erecting the corresponding transport values as follows. We will carry 7 pallets of 500 kilograms from the Bremerhaven container terminal at the Munich Trade Fair Center. As a vehicle, we will use a 40-ton, 400 horsepower strong truck with a maximum payload of 25,000 kilograms of Type 3 Euro with a full load power consumption of 31.4 liters of diesel and a no load power consumption of 21.3 liters of diesel, which the CO2 factor of a 2.629 kilogram per liter is similar. The loading weight is 7 times the weight of a pallet, which gives the sum of 3,500 kilograms or 3.5 tons. The distance from our starting point in Bremerhaven to Munich is, according to Google Maps, 819 kilometers. In our first example calculation, we assume a good utilization. As a basis, we will take the exact same values as in our first example calculation. The difference lies in the fact that in addition to the charge with 7 pallets, a second charge of a total of 11,500 kilograms will be added. Thus corresponds to the load weight of the first charge of 3,500 kilograms plus the second charge of 11,500 kilograms, which gives us a total weight of 15,000 kilograms or 15 tons. If we now apply our two formulas for energy and emissions calculation, we can set up the energy consumption and emissions for both our transport examples as follows. In our first example, we have an EV of 22.71 liters per 100 kilometer and a maximum emission value of 0.5970 kilograms to 1 kilometer. In our second example, however, we have an EV of 27.36 liters per 100 kilometer and a maximum emission value of 0.7193 kilograms to 1 kilometer. Now, if we assume that our second example corresponds to a charge of approximately 4.3 times the charge of our first example, the slightly higher consumption values of our second example are comparably small. In other words, we share the same charge of our second example corresponds to partial charges on the charge of our first example. We would emit about 3.5 times the amount of emissions and 3.5 times the amount consume energy. With that in mind, we can see quite clearly it pays well to send transport vehicles with a good load on the way. Our environment will certainly be the winner. Let's look quickly the total amounts of these two examples. In the first example, multiplying the 0.5970 with the 819 kilometer then gives us CO2 emissions of 488.94 kilograms. This corresponds to 171 grams of carbon dioxide per ton kilometer, 0.5970 divided by 3.5 tons by 1,000. Whereas in our second example, multiplying the 0.7193 with an 819 kilometer CO2 emissions of 589.11 kilograms for the total charge of 15 ton results. For the 7 pallets is a CO2 footprint of 137.43 kilograms, 0.1678 times 819 kilometers. This gives 48 grams per ton kilometer, 0.1678 divided by 3.5 tons by 1,000.